Welcome to NSMO, the National Science and Mathematics Olympiad. Today we are going to learn about atomic structure and subatomic particles. An atom is made up of two main regions, the nucleus and electron cloud region. The nucleus is located at the center of the atom. It has very high density and carries a positive charge and contain most of the atom's mass. Surrounding the nucleus is the electron cloud, which is the region where electrons move rapidly around the nucleus. The atom is made up of three fundamental subatomic particles: protons, B, neutrons, N, and electron, E. We can see in the diagram here that the nucleus contains protons, which are positively charged, and the neutrons, which have no charge. The electrons are located in the electron cloud outside the nucleus and carry negative charge. Now let us answer the question about atomic mass units. The unit used to measure atomic mass is the atomic mass unit, or AMU. One atomic mass unit is equal to 1/12 of the mass of carbon-12 atom. Carbon-12 is a particular type of carbon atom with 6 protons and 6 neutrons, a very common and stable form of carbon. By definition, one carbon-12 atom weighs exactly 12 AMU. This means that 1 AMU is approximately equal to the mass of one proton or one neutron. The atomic mass unit was introduced because measuring atomic masses in grams is very difficult, since the values are extremely small. That's why now for hydrogen atom, which has one proton, is about 1 AMU. The helium atom has 2 protons and 2 neutrons, is about 4 AMU. A carbon-12 atom, 6 protons and 6 neutrons, is 12 AMU by definition. An oxygen-16 atom, 8 protons and 8 neutrons, is about 16 AMU. Now let's examine the table of subatomic particles. A proton symbol with B plus is located in the nucleus and has one positive charge and a relative mass of 1 AMU. A neutron, N, symbol N0, is also located in the nucleus, has no charge, and relative mass of 1 AMU. An electron with a symbol E minus is located in the electron cloud and has one negative charge and much smaller relative mass of about 1/1840 AMU. This explains why electrons contribute very little to the total mass of the atom. Most of the volume of the atom is actually empty space, occupied by these fast-moving electrons. Proton, positively charged particles found in the nucleus, the atom center. A neutron, neutral particles, no charge, also in the nucleus. Electrons, negatively charged particles that zoom around the nucleus in the cloud. The nucleus accounts for more than 99.97% of the atom's mass, but it occupies only about 0.0001 of the atom's volume. Because the atom is electrically neutral, the number of protons in the nucleus equals the number of electrons surrounding it. The only exception is the hydrogen atom, whose nucleus contains one proton and no neutrons. The image here comparing the atom to an orange helps us to understand atomic size. If an atom were enlarged to the size of an orange, then by the same scale the orange would be as large as the Earth. That is how incredibly tiny atoms are. This shows that the atoms are very, very small. In this section, we will learn about atomic number and mass number. What is meant by the atomic number and what it is relation to the periodic table of element. We'll start with the atomic number. The atomic number, symbol Z, is defined as the number of protons in the nucleus of an atom. In neutral atoms, the atomic number is also equal to the number of electrons, because the positive charge of the protons is balanced by the negative charge of electrons. The periodic table of elements is arranged in rows and columns according to increasing of atomic number. This means that as we move through the periodic table, each element has one more proton than the element before it. Now let's move to a mass number. The mass number, the symbol A, is defined as the total number of proton and neutron in the nucleus of an atom. So we can write the mass number A equal number of proton plus number of neutron. Number of neutron equal mass number minus number of proton. Number of proton equal mass number minus number of neutron. This relationship allows us to calculate the number of subatomic particles in an atom. Now let us explain the notation shown in the diagram in the symbol XAB. X represents the element symbol. A represents the mass number. B represents the atomic number. Now we have to explain the exercise using the periodic table data for silver. The element shown is silver, with a chemical symbol is Ag. The atomic number of silver is 47, which means it has 47 protons. In a neutral silver atom, the number of electrons equal to the number of protons, so it also has 47 electrons. The value of 107.8682 shown in the relative atomic mass of silver, which represents the average mass of silver atoms found in nature. Now let's move to the other exercise. We are asked to find how many protons, neutrons, and electrons are present in H3-1, which is hydrogen isotope with a charge. First, hydrogen atomic number is 1, so it has 1 proton. The mass number is 3, which means the number of proton and the neutron is 3. So the number of neutron, it will be 3 minus 1 equal 2. The charge is minus 1, which means the atom has one extra electron, compared to a neutral of hydrogen atom. A neutral hydrogen has one electron, so this ion has 2 electrons. So the final answer is 1 proton, 2 neutron, and 2 electron. This example shows how atomic number, mass number, and charge work together to describe an atom completely. Thank you for listening, and with my best wishes for your success.